Yo, what's up, pre-calculus students? Mr. Mester back at you. If I did the second homework video, I might as well do the third, right? We're going to continue on with polar graphing, only we are going to venture in the world of negative radii. We understand from the first lesson that if you have an r that is negative, just one example, you would go to the angle of pi over 3. Here's the angle of pi over 3. Oh, that's a little bit too extreme. Here's the angle of pi over 3, 60 degrees. We'd go in the opposite direction. So I'd go a distance of 2 away from that terminal angle. So somewhere around there. So that's important. Things get more complicated. That's just great connection. We've just developed just this bam, bam, I've never, no. Things get tougher when the radii are negative. Let's look at some basic graphs where radii are negative. I'm talking about r equals negative theta from 0 to pi over 2. That means if I think about an angle of 0, I'm going to have a theta of 0. This is the toughest point to understand that it's not an x and a y, it's an r and a theta. 0, 0 still exists. But if I think about an angle of pi over 2, my radius is going to be negative pi over 2. So an angle of pi over 2, which is 1.5, my radius is going to be negative 1.5. If I think about an angle of pi over 6, my radius is going to be negative pi over 6. An angle of pi over 4, the radius is negative pi over 4. An angle of pi over 3, that's going to be close to 1, negative pi over 3. We actually get this opposite squiggle, opposite spiral. We're going to spiral out, opposite of what we expect. That might be tough to understand, but the next one should be easier. If my radius is negative 2 between pi over 2 and pi, what does that look like? Well, at the angle pi over 2, I don't want to have a radius of 2. I have a radius of negative 2. At the angle 2 pi over 3, my radius is negative 2. 3 pi over 4, negative 2. 5 pi over 6, negative 2. Pi, negative 2. This would be the creation of r equals negative 2 from pi over 2 to pi. It's opposite of where your angles are. You want to think about your angles going here, 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 here. Just your radiuses are plotted opposite over there. Okay? R equals negative 4 from pi over 3 to 2 pi over 3. Here's pi over 3. So there's my terminal angle. Here's 2 pi over 3. Here's my terminal side, really. But I want the radius of negative 4. Where does it start? Where does it end? Well, here would be the first point. If I plug in pi over 3, my radius is negative 4. Then my second point would be, I don't know, as I get closer to pi over 2, I would get this point. Next point, all the way to 2 pi over 3, I'd get negative 4. So I would start here, and my graph would go this way. It's important. The direction, the start and the end. The start and the end. The start and the end. Again, I don't love this one anymore. I love the spiral when you see it, but if you're creating it, it's tough. If I start at 0, I end at 0. I start at negative pi. Well, here's negative pi. This is kind of like a trick. Your radius, okay, ready? If your angle is negative pi, your radius is negative pi. If your angle is negative pi, your radius is negative pi. That's the point, negative pi, negative pi. Let's do a pi over 4. If your angle is negative 3 pi over 4, your radius is negative 3 pi over 4. Let's do the pi over 3s. Never mind. Pi over 3s are easier because they're like whole numbers. If your angle is minus 2 pi over 3, how do I know that's minus 2 pi over 3? 0 going in this direction is negative. If your angle is negative 2 pi over 3, your radius is negative 2. So at this angle, I'm going to go that way, 2. If your angle is negative pi over 2, your radius is negative pi over 2. There's that 1.5. If your angle is negative pi over 3, your radius is like negative 1. And then if your angle is 0, your radius is 0. So it's created the following way. Here is the start, and we're going to be spiraling inwards here. Not spiraling outwards is what we're used to. Another one. If your angle is negative pi, your radius is negative 1. So if your angle is negative pi, pi divided by negative pi is negative 1. If your angle is negative pi, your radius is negative 1. That is the point, negative 1, negative pi in polar form. If your angle, we'll do the pi over, well, we can do all of them because it's easy. If your angle is negative 5 pi over 6, your radius is 6/5, so 1.5. Negative 6/5. Your angle is negative 5 pi over 6. Pi divided by 5 pi over 6, negative 5 pi over 6 is negative 6/5. So at this angle, I'm going to be looking at a 1.125, I think. What's a sixth? 1.16667. Oh, right there. If your angle's negative 2 pi over 3, your radius is 1.5. Negative 1.5. If your angle is negative pi over 2, your radius is negative 2. If your angle is negative pi over 3, your radius is negative 3. If your angle is negative pi over 4, your radius is negative 4. We can kind of see this outward spiral. It's not really an outward spiral. Like this graph will spiral inwards, but the way we're creating it here with these negative angles that we're plugging in, which create negative radiuses, I mean, it kind of goes opposite of what we expect. This is a trick. I designed this just because, like, remember, positive radiuses. Negative 5 pi over 6 over here, radius of 3, there. Negative 2 pi over 3, the radius is 3. We're going towards that terminal ray. The radius of negative pi over 2, the angle of negative pi over 2, the radius of positive 3, going in that direction. All the way to the angle of pi over 6, negative pi over 6, we're going in that direction. So this would be the graph, kind of like what we expected. The only difference is I threw in negative angles, but just because we have negative angles doesn't mean we have negative radii. So like this was a little like trick. We don't have negative radiuses, we have positive. Okay. Now we're going to see how that's going to having negative radii, how that's going to change the graphs that I'm looking at. I'm going to get out Desmos, we'll be able to see it. Most of our questions won't involve sketching. Now you see this is a long homework, but most of these questions will not involve sketching, okay? Rather, it's just going to be an analysis of either our rectangular form, which will then lead to your understanding of what the polar form would look like. Or like if you see a polar equation, understanding what, like how it's created, okay? So this is the only one we're gonna like sketch. Here's the key. I'm gonna get Desmos out to show this. We learned in class, if your radius is negative, our understanding of going towards and away from the origin completely flops. Now, let's see how this is created. We're going to go from 0 to 2 pi, step of 0.01. Here's how this graph is created. And you'll be able to see this from the rectangular form. We would stop right here. As of last class, I'd say, stop here. We're done with positive radiuses. But now this class, we're going to go on. And we're going to see that my angle is going to be over here in the second quadrant, but my graph's going to be in the third and the fourth and the first quadrant. Why? My angle in the second quadrant will produce negative radiuses. Then my angle starting in the third quadrant would have negative radiuses until we get to a specific angle that then has our radiuses be positive again. We create this graph with this inner loop. Again, here's how it's created. We have positive radiuses. At some point, we're going to stop. Our radius is 0. We'll have negative radiuses. We'll see why in a second. And we'll have positive radiuses. It's going to be important to find these zeros. Guess what? This is like unit 8. Solving. When does 2 plus 4 cos theta equal 0? Well, subtract 2 divided by 4, cos theta equals negative a half. We're talking about 0 to 2 pi, so we don't want all of them. Cosine's equal to negative a half. We look at our tall 30, 60, 90. When the adjacent is a half, that's going to be at the pi over 3's. The pi over 3's, where cosine is negative, is the second and the third quadrant. We want the angle 2 pi over 3 and the angle 4 pi over 3. Okay, good start. Second thing. We're going to sketch the rectangular form, one period. We can see we have a vertical translation. We got a midline adjustment. We can say we have a vertical dilation. We have an amplitude. We're going to go up to 6, but we're going to go down to negative 2. Now, remember when I talked about, like, what are the easy values to plug into cosine? The values where we get half. It ends up at the pi over 3's. Watch how that's going to play out here. We got pi over 2. We got 3 pi over 2. We got 0, 6. We got pi over 2, 2. We got pi negative 2. We got 3 pi over 2, 2. We got 2 pi 6. But if we go to the pi over 3's, in particular, 2 pi over 3 and 4 pi over 3, what do we have? Zeros. This point, very important. This point, very important. Sure, we'll have 4 at pi over 3, and we'll have 4 at 5 pi over 3. 5 pi over 3 is closer to 3 pi over 2. And pi over 3's are easy because it just halves my amplitude for cosine. We have this graph, and that's helpful. But once we go into negative radius land, all of our conceptions about what's going on change. Typically, we see that if our rectangular graph is going down, the radius is decreasing. No longer. The distance, the radius is decreasing, but the distance is no longer going to decrease. And this is what's important. We go from 0 to 2 pi over 3. Boom. There's where I get that radius of 0. Now, that's frustrating. I should just do 2 pi over 3. Okay. Now, after 2 pi over 3, here we have this negative radius line. You can see that your radius is decreasing, but since it's getting further away from 0, the negative radius is producing larger and larger negative values. All of a sudden, you can see we are going away from the origin right now. Now, typically you see a radius increasing. You would think, oh, radius is increasing. That means the distance is increasing. No longer. If you have negative 2 to 0 values of a radius, you are going to get it closer to the origin. So what we have to deal with and what we're talking about in class is Once radiuses are negative, things almost flip-flop. We no longer look at just things going down or going up, but rather, are they getting closer to zero or further away than zero? Are they positive and decreasing? We're getting closer to the origin. Are they negative and increasing? We're getting closer to the origin. Hopefully we understand that. That's the biggest thing. Graphing, 0, 6, okay? Pi over 3, 4. 1, 2, 3, 4. Don't go past the arc of 4, so we kind of curve, kind of stay in the channel between 6 and 4. Pi over 2, 2. Don't go past things, just kind of curve. 2 pi over 3, 0. Don't go past the line of 2 pi over 3. Get to 0 by the time you get to 2 pi over 3. Don't go past it. Now here comes the fun part. Pi, negative 2. Pi, negative 2. How do we get there? We create this inner loop where my angles between 2 pi over 3 and pi are right here. That means I need to be between 5 pi over 3 and 0. So I probably went a little bit too far. If you want to zoom in, you can see you got to keep this between 5 pi over 3, which is opposite 2 pi over 3, and then 0 right there. Then from pi to 4 pi over 3, we go back to 0. We go from a radius of negative 2 to 0. We can't go past this 4 pi over 3 angle in the opposite direction. We have to go back to this radius of 0, but up to this 4 pi over 3 terminal angle, and it's opposite. Then we have 3 pi over 2, 2. Between 4 pi over 3 and 3 pi over 2, we're going to stay in this channel between these terminal angles, between these radii. 5 pi over 3, 4. Between these two angles, we will be between these two radii. And then 2 pi 6. Between 5 pi over 3 and 2 pi, we need to be between 1, 2, 3, 4, and 6. There you go. When is the distance between the graph and the origin increasing? The distance is increasing here when it's positive and increasing, but also here when it's negative and decreasing, when it's getting further away from 0. So 2 pi over 3 to pi, as well as 4 pi over 3 to 2 pi. And this is tricky, guys. This is tricky. So like you gotta understand your graph. You gotta understand what happens if your radiuses go negative. Okay? Now, you'll have certain questions where it won't be something that you're gonna be graphing like rectangularly. Rather, it's like, hey, I mean, it's not a trig function you're graphing rectangularly. Rather, it's 4 minus theta squared. You know, well, if I looked at y equals 4 minus x squared, what does that look like? It's a polynomial function. You know, like when you factor polynomials, which you hopefully will do correctly. When you factor polynomials, you kind of understand where the zeros are. Many of you will go straight to the graph and you'll be like, okay, 4 minus x squared, it's going to be looking down. We got this positive 2 and this negative 2 value. Many of you will go right here. Those of you who are not comfortable with that, we use a sign analysis. And we say we got 2, we got negative 2, we got 2. If I plug in something like 5, 2 minus 5, 2 plus 5 is negatives. We'll change signs because of multiplicities. Cool. Now, this rectangular graph is then thought of as for angles, what are my radii? Well, between 0 and say 0.2, you can see like between 0 and 0.2, my graph hit a maximum. I mean, these are bad. I should have gone from -2 to 0.2. I was thinking like, anyways, you can see that my radius is decreasing. But from 2 to 2.1, you would say, oh, it's still decreasing, right? It's still going down. But no, my radius, which is my y values, hit a 0 at 2. They go from 0 to negatives. Now think about radiuses that are going from 0 to negatives. They're getting more negative. They are going away from 0. They are actually going to produce a situation where we're increasing. Negative radii getting more negative. It's like you look at the absolute value of your radius. So here, like this is a radius equals 0. These are radiuses that are positive getting more positive. You'd say the distance between the origin is increasing. Here are radii that are getting positive and less positive, positive and decreasing. So you're going to say that the distance is decreasing. But here, like bells and whistles go off. We are negative radii. Negative and getting more negative, we would say the distance is increasing. Negative but getting less negative, we'd say the distance is decreasing. So it like flips when you go negatives. But don't memorize this, just understand it. I'm going to go straight to just 0, 2, and 6. If you'd like to graph the rectangular version, that's fine. You can graph the rectangular version. It's a positive x cubed, 0, 2, and 6. Or you can do sign analysis. These are your zeros of your radii for these angles. When my cursor comes back, there's a 0 of our radii. Here are the radii getting positive. We can see that between 0 and 0.2, like right here, my radii are positive, getting more positive. So the distance between the origin and my graph is increasing. Between 2 and 2.1, that's like right here. You can see the radius is negative, but getting more negative. That means the distance is going to increase as well. Negative radius is getting more negative. We saw that with that inner loop. 5.9 to 6, we're right here. We can see our negative radiuses are getting closer to 0. If your radii get closer to 0, you are going to be going towards the origin. If your radii are moving away from 0, you're going away from the origin, so this is decreasing. The other ones, it helps to have the graph. We have our midline, we have our amplitude, we have one period, we have zeros. Well, the zeros are going to be when we have things. So 3 plus 6 cos theta equals 0. We're going to see that at the pi over 3s. Again, 2 pi over 3 and 4 pi over 3. We're going to have our zeros. This is -3. We'll see at all of our pi over 3s, we're going to like have things. And we can see that having this will produce a 0 when cosine's negative. So I'm going to include 0, pi over 2, 3 pi over 2. But we kind of alluded to last class how having the halves, cosine's halves are the pi over 3s. Sine's halves are the pi over 6s. Don't forget that difference. Cosine does start at a maximum. We have pi over 3. We'll have pi over 2. We have 2 pi over 3. This is important. Radius of 0. All of a sudden, things change. We're now looking at going towards or away from 0. No longer are we looking at just going up or down. We're looking, are we going towards or away from 0? From 0 to pi over 2, we can see we have positive radiuses, 9, 8, 7, 6, 5, 4, 3. So they're decreasing. They're getting closer to 0. From pi over 2 to 2 pi over 3, we can see we have positive radiuses that are getting closer to 0. So that means my distance, I don't even have to look at the graph. We can sketch the graph. It's going to be one of those inner loops again. We don't have to. We can just understand the rectangular graph to understand what the polar graph is going to look like. Between 2 pi over 3 and pi, okay, be careful. We have negative radii, getting more negative. We're going 0, -1, -2, -3. Radiuses of -1, -2, -3 will be pushing the graph away from the origin. So this is actually increasing. Pi to 2 pi over 3. That should be a 4 pi over 3. That should be a 4 pi over 3. Whoops. Pi to 4 pi over 3. Negative radiuses that are going closer to 0. Closer to 0. Decreasing. 4 pi over 3 to 2 pi over 2 pi. Increasing and positive. Increasing. If you want to see what that looks like, you could, but it's the same here. Just 3 plus 6 means everything's going to be bigger. We go from 0 to 2 pi over 3, and you can see my distance is decreasing. Let's go into the polar graph so you can see how it's going to fit inside the radii, how it keeps going to smaller and smaller radii. Boom, we get a 0 at 2 pi over 3. From 2 pi over 3 to pi, we are going away. This is going further and further away from the origin. But then pi to 4 pi over 3, we're getting closer to the origin. But then from 4 pi over 3 to 2 pi, we're getting further away. Okay, there's a lot more, but it's all the same. And then we'll talk about maximum and minimum distances. It's a little repetitive. You'll be fine. I'm back. I gotta find the homework. All right. Where were we? We graphed one. We looked at these. I think we're on this one. Okay, so like you gotta understand negative radiuses. You gotta understand if your radius is getting closer to 0, you're getting closer to the origin. If your radius is getting further away from 0, you're going away from the origin. You have to understand that. Zeros are important. Now, we're probably going to find that all of our zeros are going to be the nice numbers of our cosines and our sines. What do I mean by the nice numbers? Pi over 3 is for cosine. Pi over 6 is for sine. If it's not, well, you can strike me down. This is the same deal. Cosine theta equals -1/2. That's going to be at 2 pi over 3 and 4 pi over 3. So as you're like graphing this, you could consider 2 pi over 3. You could consider 4 pi over 3. We probably want to add the other pi over 3s just because we will be applying, half of our amplitude. So the pi over 3s, first and fourth. We got 3, 4, 5.5. Wait, 9 to 3 is 6. So this is 6. This is 0. Bam. Okay, so we go 9 to 6 to 3. 0 at 2 pi over 3. -3. 0 at 4 pi over 3. I found that. 3, 6, 9. This line, the line of the zero radius being your important line, will show you, bam, there, my radiuses are getting further away from zero, negative and decreasing, going away from the origin. Here, going towards the origin. So let's just answer that. This is increasing, this is decreasing, and then the rest makes sense. Decreasing, decreasing, increasing. All right, same deal. It's like you're all worried about this. Don't be worried about it. It's like we're up, we're down. We got sine. Watch. Like we're going to find the zeros. It's important to find the zeros. It's important to figure out when the radius is zero. But guess what? We're not going to give you ones that it's going to be weird angles. So I'd have to set up some equation where that has root threes in it. And it's like, I don't want to do that. So like it's always half of the amplitude getting you to the zero. It's always going to be this like pi over 6 for sine and pi over 3 for cosine. At least that's how I design them. I don't know what they're going to actually be. So this is 7 pi over 6 and 11 pi over 6. That's when sine is negative. Remember how we do this, guys? Like, I know some of you are still struggling on the unit circle. We're thinking about sine, SOHCAHTOA, when the opposite is a half. That's going to be my short 30, 60, 90 triangle. The short 30, 60, 90 triangle occurs at the pi over 6. We want the pi over 6 when sine is negative. So that's the pi over 6 here, the pi over 6 there. That's 7 pi over 6 and 11 pi over 6. So we got a period. We're not asked to sketch, but this is the idea of like where inner loops come from, or repetitions or multiple loops showing up. So 0, pi over 2, pi, 3 pi over 2, 2 pi. But crossing through 0 will occur at 7 pi over 6, which is right after pi, and then 11 pi over 6. If you want to include the other pi over 6s, great. 1 pi over 6 and 5 pi over 6 would give you 4. But don't need to. But this is so important. When your radius hits 0 and then goes negative, then hits 0 and goes negative, everything flip-flops, Between 7 pi over 6 and 11 pi over 6, my radius is negative. Now, let's think about that. We're going around starting at a radius of 2 when theta is 0. We go around pi over 2. We're going to have a radius of 6. Cool. We get to pi. Great. We get to 7 pi over 6. Boom, there's the radius of 0. 7 pi over 6 right here. You see how my radius is getting closer to 0 between the angles pi and 7 pi over 6. Then, from 7 pi over 6 to 11 pi over 6, between these two angles, my radius is going to be negative. It goes all the way to negative 2. Boom, that's 11 pi over 6. Right there, 11 pi over 6. And from 11 pi over 6 to 2 pi, we go back from 0 to 2. That creates this inner loop. We have to understand that radius is increasing. It's going away from the origin. This is decreasing. This is also decreasing, but this is now increasing. We are negative and getting more negative. Here we are negative and getting less negative. We're getting closer to the radius of 0. If you look at the graph, we were going away from the origin and then back towards the origin. So this is decreasing. This is increasing. All right, let's do some adjustments. Period is 2 pi divided by 3. We're going to step out and be pi over 6. So pi over 6, 2 pi over 6. I'm going to graph 2 periods. 3 pi over 6. 4 pi over 6. This is 1 period. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. 12 pi over 6. Okay. Now, all the zeros are going to be at the pi over 6s. If you wanted to solve that, cos 3 theta equals 0. Okay. What angles? This cosine equals 0, and all the verticals. Adjusted becomes pi over 6s and pi over 2s. So, I mean, you could just kind of see that. Pi over 2, pi over 6. Pi over 6, pi over 2. Pi over 6. And what happens is like a cool graph that's created. From 0 to pi over 6, positive radius going closer to 0, decreasing. From pi over 3 to pi over 2, negative radiuses that are getting closer to 0, decreasing, are getting closer to the origin. Distance is decreasing. Pi to 7 pi over 6, we are, same thing, decreasing. 4 pi over 3, oh shit. That's 4 pi over 3, never mind. 4 pi over 3 to 3 pi over 2, decreasing. 3 pi over 2 to 5 pi over 3. Oh, we got an increasing. We have negative radiuses that are getting more negative. They're getting away. 5 pi over 3 to 2 pi. Both. It's decreasing until 11 pi over 6. And then it's increasing from 11 pi over 6 to 2 pi. Here's what we're seeing. Let's kind of look at this at the same time as Desmos. From 0 to pi over 6, my radiuses go from 2 to 0. Boom. From pi over 6 to pi over 3, I get to a radius of negative 2. Boom. So from pi over 6 to pi over 3, my radiuses are negative. So that's really like between 7 pi over 6 and 4 pi over 3. Okay, then I go back to a radius of 0. Now we're going back to positive radiuses from pi over 2. We go out to 2 pi over 3. Then we go back to 0 by 5 pi over 6. At 5 pi over 6, I hit another 0. Then, from 5 pi over 6 to pi, from 5 pi over 6 to pi, I have a negative radius. Boom, I've just created the graph. We hit pi, and we've created the graph. Well, what happens after that? Well, watch. From pi to 2 pi, from pi to 2 to a, from pi to 2 pi, the graph is recreated in the same way. But from pi to 7 pi over 6, these radiuses are negative. We're doing pi to 7 pi over 6. So my angle, my terminal ray is over here, but the radiuses are negative. From 7 pi over 6 to 4 pi over 3, we have positives. Here's positive radiuses in the third quadrant between 7 pi over 6 and 4 pi over 3. And then 3 pi over 2, we get back to a 0. Here, 3 pi over 2, we get back to 0. Now in the fourth quadrant with our angles, but the graph is traced over in the second quadrant. Now, 11 pi over 6 to 2 pi, finish off. So it's like really tricky how this stuff works, but you got to understand if your radius is negative, your angles might be here, but your graph is down there. Okay, where's the distance decreasing? We shift down 4. This is tricky. We are up 8. Okay, this is a tricky graph because we're starting at a negative radius. We're going to a radius that's 0. So 0, we're going to have to find, not 0, it's the midline. Let's find the zeros. It's going to be at the pi over 6s again. 1 pi over 6 will be half. So like you could check 8 sine theta minus 4 equals 0. Sine theta equals positive a half. Here it's the positive pi over 6s. Pi over 6, 5 pi over 6. Okay. So boom, we get a max there. Pi over 6 is way over here. It's right after 0. Here's half of my amplitude. 0, max, 0, midline, minimum, midline. When is the distance between the graph and the origin decreasing? Getting closer to 0. Getting closer to 0. Getting closer to 0. That's what you got to look at. Negatives increasing, positives decreasing. So we're talking about 0 to pi over 6, pi over 2 to 5 pi over 6, 3 pi over 2 to 2 pi. Okay, maximum distance from the origin could occur at max or min r's. If r is -7, and that's the location of a min, and r is 5, and that's the location of the max, guess what? -7 wins for biggest distance from the origin. So really all you have to care about these is the graph. Again, quickly, you will be able to know that I'm going to go up to 7 as a positive and down to -3 as a negative. This would be the location of the max. We know this is 0, pi over 2, pi, 3 pi over 2, 2 pi. 0 and 2 pi are my angles where I'd have the max. But if things get flipped, how am I flipping? Well, now my midline's at -2. If I go an amplitude of 5, I go up to +3, I go down to -7. -7 as the radius would be the location where we're furthest away from the origin. That's all we have to do for this. Understand that the largest value, absolute value, would produce our biggest distance away from the origin. So 0 pi over 2, pi, 3 pi over 2, 2 pi, we're going to be talking about pi. And that makes sense. It's got -5 minus 2 is -7. So -3 vertical reflection. We go down, up, down. Now, oh, I screwed up here. I completely screwed up. We are at 3. We go up 1, down 1. 4 is the biggest value. When does 4 occur? At 3 pi over 2. Another way to think about this is like what's sine's maximum value, what is its minimum value, how does that affect the other stuff going on? If I have a 1, 1 minus 3 is -2. If I have a -1, -1 minus 3 is -4. The -4 is a bigger value than 2. Therefore, 3 pi over 2 is going to win here as well. We're down 3, go down 1, up 1 for an amplitude. You go up, down, up. This would produce the largest radius this would be the max distance. So this is, again, 3 pi over 2, just for a different reason. Okay. Period is 2 pi. I need to dilate it by a factor of 2, so the period is 4 pi. We got an amplitude adjustment. Both of these produce the same distance from the origin. Top, middle, bottom, middle, top, but it's every pi. So 0 and 2 pi. If I'm talking about only from 0 to 2 pi. Here, I am dilating by a factor of a half, so the period's pi. Same deal, 6 and negative 6 will be furthest away from the origin. 0, this would be pi over 4, pi over 2, 3 pi over 4, pi. I'd have to repeat. 3 pi over 2, no, 3 pi over 4, 5 pi, oh gosh, pi over 4, pi over 2, 3 pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. Bam, 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 bam. Cool.
What if she got one that can't live in that tank? It's dies. I don't know what we get fish food, just feed it. That one's dead, so what is it gonna eat?
6 pi divided by 4 is 3 pi over 2.
2 days, hopefully. Probably. I don't know if it gets like a last feed though. Maybe it wasn't fed the day before.
Just gonna leave it at that. That's between 0 and 2 pi.
You see that surprise us? Like, we didn't know that we needed fish until last class. She's like, oh, by the way, I feel like there's other stuff that's gonna be like, oh yeah, by the way, you needed to do this, and we didn't let you know. Yeah, she didn't tell us that.
Hold on. We got 2 pi over 3 is one period. That means 4 pi over 3 is another period. That means 6 pi over 3 is a third period. And that gives us to 2 pi. So what's this stepped out? Pi over 6. 0. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10, 11, 12. That's my graph from 0 to 2 pi. This is one of those graphs that repeats itself. 4 and negative 4. 1 pi over 6, 2, 3 pi over 6. 4, 5 pi over 6. 6, 7 pi over 6. 9 pi over 6. 11 pi over 6. I think this is easier than if you're solving the equation 4 sine. No, this is the way to do it. All right, until later.